In today's video, we're going to be talking about simultaneous equations. Simultaneous equation is a technique for solving two equations at the same time. In this video, we're going to be looking at a real-life application of the simultaneous equations. Let's use this example to demonstrate that. Dracado manufactured chairs at $2 each and tables at $3 each. He retailed 40 furniture and made $100. A. State two simultaneous equations depicting the above information. B. Solve the equations to find how many chairs and tables retailed. Right, so to solve this question, we have to, try to do some representations or denotions. We're going to represent the chairs and the tables by some variables. So let us say, let X denote chairs, right? And then Y denotes tables. Okay, right. So after this denotion, the total furniture according to the question is what? He retailed 40 furniture. So the furniture we're talking about here is chairs and tables, right? Total furniture, that is X and Y is equal to what? 40. Okay, so you see the X denotes the chairs and then the Y denotes the table. That is why we take some Y here, right? So the furniture we're talking about is chairs and tables, right? And then he made how much? He made $100, right? So amount is equal to $100, right? So we're going to look at actually what we're doing is we're solving A, right? We're solving A. So we're going to, the A says that we should state the equations depicting the above information. So based on the question, Dracado manufactured chairs at $2 each and tables at $3 each. He retailed 40 furniture and made $100. So we have X representing the chairs, right? So the chairs plus the tables, the Y, in total, they are how many? They are 40, right? They are 40. And then also, each chair costs how much? According to the question, each chair is, $2, and each table is what? $3. So to know the amount, each chair costs $2, right? So if we have X chairs, the price of X chair is going to be times 2, right? Plus the number of tables. Each table costs what? $3. So, and tables, Y depicts tables, right? So we're gonna have 3Y, and the total number of the chairs and the tables sold amount to this price, $100. So we're going to have 100 here, right? So these are the two equations that we can derive from the information that we are given in the question. Now the B says that solve the equation to find how many chairs and tables retail. So over here we're going to find the number of chairs that Ricardo retailed, as well as the number of tables that Ricardo retailed to make this $100, right? And that is B. And to solve it, then we're going to need to solve the two equations that we found simultaneously. Okay, simultaneously. So let's state them. We have x plus y equal to 40. So this is going to be equation 1. Then we also have 2x plus 3y equal to 100. And this is going to be our equation 2. Right. Now solving this, we're going to use substitution method, right? So with the substitution method, let us try to make one of the variables the subject from any of the two equations. I think it is easy to make it the subject from equation 1, right? So we are making x subject from equation 1. Then we're going to have x is equal to 40 minus what? Y. You know, to make x the subject, we need to let x stand alone, and that is to say that we need to send this y across the equality sign. The y is positive. When it crosses this equality sign, becomes what? Negative. That is why we have minus y here. Okay, and this one is going to give us what equation? Equation 3, right? So what we're going to do next is to put equation 3 into equation 1. To put equation 3 into equation 2. So we had equation 2 is 2x plus 3y equal to 100, right? And equation 3 is x is equal to 40 minus y. So put equation 3 into equation 2, and equation 2 we had 2x plus 3y equal to 100, right? So wherever we see x in this equation 2, we're going to write what? Wherever we see x, we're going to write, in place of x, we're going to write 40 minus y. Okay, wherever we see x, x is equal to 40 minus y, right? So we have 2, in place of x, we have 40 minus y plus 1. 3y equal to 100. Then we multiply the 2 through. We're going to have 2 times 40, that is 80. 2 times minus y, we have minus 2y plus 3y equal to 100, right? So So simplifying, we're going to have here minus 2y plus y. We're going to have y equal to 100. Then this 80, when we send it across the equality sign, minus what? 80. So simply y will be equal to 100 minus 80. That will give us what? 20. Right? 20. And then what we're going to do next is we found the y, which denotes the tables, right? So it's left with the chairs. So we need to find x as well. So put y equal to 20 into equation 3. And equation 3, we said equation 3, x is equal to 40 minus what? Y. That's equation 3, right? That's equation 3. X is equal to 40 minus y. We'll write it here. X is equal to 40 minus y. That's equation 3. So we're going to have x will be equal to 40 and y is equal to what? 20. So in place of y, you write 20 there. 20. So my x will be equal to 40 minus 20. That will give us what? 20. Right? So therefore Ricardo retailed 20 chairs and 20 tables. So we done solving the simultaneous equation. We say that we should state two simultaneous equations depicting the information, and these are our equations, right? Yeah, these two, these are the equations. And then upon solving those equations, so we should solve them to find so we should solve the equations to find how many chairs and tables were retailed. And upon solving it, we had 20 tables and also 20 chairs. So that's all. We're done solving the question. If you find this video interesting, you subscribe.